So we will start Unit 4 from today onwards. Unit 5 material clearly available in your Google Classroom, and refer my video lecture also. Understand the concept clearly. Okay, don't bygot any of the equations involving in three types of sampling method. All the equations are very simple, but you should understand the basic concept as well as properties of Fourier transform, and how to derive Fourier transform of a signal, or how to derive inverse Fourier transform of given h of j omega. Okay, so only that those concepts you should remember. Okay, don't bygot any of the equations. Understand the concept and study well. Unit 4 deal with discrete time Fourier transform as well as Z transform. We have only two mathematical tools available in Unit 4. Previously, we have three, DTFT and then DFT and then Z transform. So I think we have removed DTFT from your syllabus. So only DFT we have removed, and DTFT is a transform. Only these two things are available. Because DFT you will be studying in digital signal processing subject. Okay. For continuous time signals and system analysis, we discussed Fourier series for periodic signal representation, Fourier transform for aperiodic signal representation as well as periodic, and for unstable signal analysis also we used Laplace transform technique, right? So three mathematical tools we studied for analyzing continuous time signals and system. So similarly, for analyzing discrete time signals and system, we have two mathematical tools, DTFT and Z transform in our syllabus. Okay. DTFT of a discrete time signal x of n. DTFT of a discrete time signal x of n represented by x of e power j omega. So this is the representation of DTFT. Continuous time Fourier transform, CTFT representation x of j omega. Okay. So discrete time Fourier transform representation x of e raised to j omega. The formula summation x of n e power minus j omega n, where n varies from minus infinity to infinity. So this is DTFT of a discrete time signal x of n. Similarly, inverse DTFT of x of e power j omega, that is x of n. X of n equal to 1 divided by 2 pi integration, general formula minus pi to pi. Depending on the signal, the integration limit will be changed. X of e power j omega, e power j omega n into d omega. Okay, so this is the formula for inverse DTFT. So using this formula, we are going to solve some basic signals first, and then properties, and how to use DTFT properties for analyzing discrete time LTE system, for finding transfer function or impulse response or step response. Okay. Next, existence of discrete DTFT. Whether this DTFT can be applicable for all these signals? No. So we studied the Triglet condition, right? Triglet condition for Fourier series as well as Fourier transform. Similarly, DTFT also has certain condition. Existence of discrete time Fourier transform. So what is the condition? A discrete signal, the given discrete signal should be absolutely summable. Summation n minus infinity to infinity x of n, your result must be finite. Okay, or otherwise called as the x of n signal must be absolutely summable. meaning only stable signal will give this result, right? Summation minus infinite infinite x of n less than infinite. This will be true for only stable signals. So DTFT can be applicable only for stable signals. Then we move on to Z transform by assuming some condition, that is region of convergence. With that concept, we can apply the Z transform both stable signal as well as unstable signals. How? CTFT Laplace transform. In the similar manner, DTFT is a transform. Right? DTFT for applicable only for stable discrete signals. Z transform, we can analyze both signal, stable signal as well as unstable signal, but we are writing some condition called as region of convergence. Okay. So basic problems using DTFT. First problem, find DTFT of del of n. This is formula, okay? Find DTFT of del of n. So we know the formula DTFT equal to x of e power j omega, x of n e power minus j omega n. N varies from minus infinite to infinite. So del of n, how to sketch the del of n signal? At n equal to 0, the magnitude of this del n is 1. Remaining all other n values, here 0. So that is the property of del of n. So summation n from minus infinite to minus 1 plus summation from 1 to infinite, 0 only. So the summation is not valid because at n equal to 0 only the signal information available. So n from minus infinite to infinite, x of n replaced by del of n e power minus j omega n. So del of n is valid at n equal to 0 only. Del of n valid at n equal to 0 only. One for n equal to 0. 0 otherwise. So del of n multiplication with e power j omega n. This multiplication product is valid, that is non-zero, only at n equal to 0. So del of 0 value 1. Wherever the small n is there in the particular equation, you replace all the small n by 0. So e power minus j omega 0. This is your result. So e power 0 1 1 dot 1 1. So del of n DTFT. DTFT. Result is 1. Or 1, if we find the inverse DTFT, result is del of n. Please remember, this is one of the basic formula of DTFT. Later we will be using this for analyzing LTE system difference equation. Okay. So next problem. Next formula actually. Find a DTFT of U of n. So what is the signal sketch for U of n? 0, 1, 2, 3 up to infinite, right? Up to infinite. It has the magnitude of 1 at each and every dimension. From minus 1, minus 2 up to minus infinite, we are getting 0 value. So this is U of n signal. Now try to find DTFT of the signal. X of e power j omega equal to general formula n equal to minus infinite to infinite. But in this example, the information valid between 0 to infinite only. So I have directly changed the limits of the summation n from 0 to infinite. Why? The reason is, according to the characteristics of U of n signal, there is no information minus infinite to minus 1, 0. So you start your summation limit n from 0 to infinite. So U of n, x of n equal to U of n. What is the magnitude? 1. So 1 dot e power minus j omega n. Okay. Basic formula minus infinite to infinite x of n e power minus j omega n. According to the given signal, change your summation limit. For summation related problems in DTFT as well as in Z transform, we will be using some standard formula. Suppose n equal to 0 to infinite a power n. The result is 1 divided by 1 minus a. The condition is modulus a should be less than 1. Second important formula we will be using 0 to n. Some other formulas also we will be using, but these two frequently used while solving the summation. 0 to n a power n, irrespective of a value, the result is 1 minus a power n minus 1 divided by n plus 1, right? 1 minus a power n plus 1 divided by 1 minus a. Right or not? So, yeah, 1 minus a power n plus 1 divided by 1 minus a. Okay. So how to write answer for this equation? N equal to 0 to infinite. E power minus j omega whole power n. 0 to infinite a power n formula. So result is 1 divided by 1 minus e power minus j omega. Okay. The conclusion here, DTFT of u of n. Result is 1 divided by 1 minus e power minus j omega. This is second important formula of DTFT. So del n u of n. And what it is Fourier transform. DTFT answer. Okay. Next signal. X of n. X of n equal to del of n minus k. We don't know what is the value of k, right? They given general n minus k. So how to plot n minus k signal? From k onwards, right? K plus 1, k plus 2 and so on. Sorry, okay. This is impulse signal, right? Okay. Del of n minus k. Del of n signal at n equal to 0, magnitude 1. Del of n minus k meaning at n equal to k, the magnitude of the signal is 1. Remaining all other time interval, the value is 0. That is del of n minus k. This k may be anything. We don't know. It's generalized term given in the problem. Now how to solve these kind of signals? DTFT of the signal. X of e power j omega equal to summation x of n e power minus j omega n, where n varies from minus infinity to infinity. So in this example, n from minus infinite to infinite, there is no information except at n equal to k. At n equal to k only magnitude. So del of n minus k e power minus j omega n. This del of n minus k equal to 1. At n equal to k, correct? At n equal to k only this information value. So result is 1. So in the remaining term, wherever n is there, this n is replaced by k. So this is your result. X of e power j omega equal to e power minus j omega k. If k is 2, here also e power minus 2 j omega. N minus del of n minus 3, result is e power minus 3j omega. It's a generalized formula. Del of n minus k dtft result e power minus j omega k. This is another formula. All are simple formulas. Similarly, u of n minus k. What is the formula? X of n equal to u of n minus k. Find dtft. So let us understand the signal sketch for un first. 0, 1, 2, 3, 4 up to infinite. The magnitude of the signal is 1. It is a discrete signal, right? Okay. So u of n minus k. N minus k. It's a delayed version of un only. So we don't know what is the k value. Let us assume k value may be anything. So from the k, the signal will be started, right? K, k plus 1, k plus 2 and so on, this value. Okay. So general formula for dtft, x of e power j omega equal to summation x of n e power minus j omega n. N varies from minus infinity to infinity. In this example, x of n equal to u of n minus k. U of n minus k, what is the starting sample? K. Okay. So n equal to k up to infinite. X of n, magnitude of the signal is 1. E power minus j omega n. So now k equal to infinite, e power minus j omega n. So there is no formula. We have summation 0 to infinite or 0 to n or n1 to n2. For that only we have formula. So how to solve this kind of equation? Try to expand it. Substitute n equal to k first. E power minus j omega k. Plus substitute n equal to k plus 1. E power minus j omega k plus 1. Plus e power minus j omega k plus 2. Plus e power minus j omega k plus 3 and so on. Okay. Now from this equation, take e power j omega k outside. So we'll get 1 plus e power minus j omega plus e power minus j omega plus e power minus 3j omega and so on. Okay. So for this equation, we can write the binomial equation. That is 1 divided by e power minus j omega, let it be. To represent this particular equation, we can write it as 1 divided by 1 minus e power minus j omega. Formula. So your result is e power minus j omega k divided by 1 minus e power minus. So this is dtft of u of n minus k. Okay. So 4 formulas we have derived so far. Del n un, del n minus k, un minus k. Remember this formula. U of n minus k. When we find dtft of this signal, result is e power j omega k divided by 1 minus e power minus j omega. Right. Next. It's very important formula. X of n equal to a power n u of n. Okay. E power minus at u of t. That we solved in Fourier transform. Okay. Here a power n u of n. So solve dt of t x of e power j omega summation x of n e power minus j omega n, where n varies from minus infinite to infinite in general, but the given signal has u of n terms. So if un available, the information valid from n equal to 0 to infinite only. So e power n u of n magnitude 1 e power minus j omega n. Okay, so rewrite this equation 0 to infinite a power n formula. If you rearrange this equation, n from 0 to infinite a power n, a e power minus j omega whole power n. So 0 to infinite a power n. This entire term now consider as a power n. So result is 1 divided by 1 minus a. Okay, so a power n un. So if we find dt of t, the result is 1 divided by 1 minus a e power minus j omega. This very important formula for solving LTE system described by the difference equations in later classes. Okay, right. So del n un del n minus k u n minus k a power n u of n. Okay, so these are all fundamental formulas of DTFT. Now sometimes you may expect the question directly. Find the DTFT of a power n u of n. Right. Next few problems. Suppose x of n equal to del of n plus 2, del of n minus 2. Now find the DTFT. Okay. What is del n plus 2 representation? Del n meaning at n equal to 0, value 1. N plus 2 meaning at n equal to minus 2, the magnitude is 1, right? So how to sketch del n minus 2 signal? At n equal to 2, the magnitude of the signal is 1. Okay, so to plot this entire signal, this signal minus this signal, you can 1 minus of this magnitude. Okay, why I have plotted this signal? You should understand this del of n plus 2 equal to 1 at n equal to minus 2. Del of n minus 2 equal to 1 at n equal to 2. This concept you should know for solving this particular problem. So x of e power j omega summation x of n e power minus j omega n varies from minus infinity. The given signal has two impulse component, right? So del of n plus 2, del of n plus 2 e power minus j omega n. I'm going to write separately, right? Minus summation n equal to minus infinite to infinite del of n minus 2 e power minus j omega n. Using linearity principle, you can rewrite separately x of n equal to 2 terms. Del of n plus 2 equal to 1 at n equal to minus 2. So e power minus j omega, this n replaced by minus 2. Okay, this product is non-zero value at exactly n equal to minus 2, even though in the formula n from minus infinite to infinite available. So according to the characteristics of del n plus 2, this product is non-zero value at n equal to minus 2 only. So the result of this summation is e power minus j omega minus 2 minus del n minus 2 value 1 at exactly n equal to 2 only. So e power minus j omega, this n replaced by 2. Okay. So the result is e power 2j omega minus e power minus 2j omega. Okay. E power j theta minus e power minus j theta. 2j sin theta. So dtft of del n plus 2 minus del of n minus 2. Answer is 2j sin omega. So like this, many problems are there in your reference book. That is Signals and System by Ramesh Babu is one of the reference book. I will try to solve as much as possible. Okay, in DTFT and also in Z transform. Next, if the sequence are provided, then how to find DTFT? Find DTFT of 1 minus 1 2 2. So far we solved the DTFT for given some signal u of n, del of n, u of n minus k, del of n minus k, a power n u of n, del of n plus 2 minus del of n minus 2 and so on. Suppose sequence given. Now find the DTFT. X of e power j omega equal to x of n e power minus j omega n, where n varies from minus infinity to infinite, general formula. X of n equal to 1 minus 1 2 comma minus 2. If the problem given like this, by default the first sample magnitude corresponding to x of 0 position, second sample magnitude corresponding to x of 1 position, and so on. Okay, so x of 0, x of 1, x of 2, x of 2. The sequence mean that 1 minus 1 2. Okay. It's the actual meaning. We studied in unit 1 different way of representation of a discrete time sequence: tabular format, sequence format, and sketching of discrete time sequence. Okay. So now your summation changing from n equal to 0 to 3, right? Because 0, 1, 2, 3, x of n e power minus j omega n, x of 0 e power 0 1, x of 1 e power minus j omega, x of 2 e power minus j 2 omega, plus x of 3 e power minus 3j omega. Because in the given problem, the samples are available from 0 to 3. From 0 to 3. Now substitute x of 0 value, 1 value, 2 value, 3 value, and complete the problem. X of 0 value, magnitude 1. 1 dot 1. X of 1 value minus 1. Minus 1 e power minus j omega. Plus 2 e power minus 2j omega. Plus 2 e power minus 3j omega. Okay. So this is the result. So in the question paper, find the DTFT of some given standard signal or DTFT of the given sequence. You should ready to solve the problem. Okay. If sequence given, expand your actual formula depending on number of samples available in the x of n signal. And then substitute x of 0, 1, 2, 3. Simplify, write down your final answer. So I told the condition for existence of DTFT. Suppose x of n equal to 2 power n u of n. Find DTFT. Don't apply your a power n u of n formula directly, because the n equal to 0 to infinite a power n, result is 1 divided by 1 minus a, when your a must be less than 1, right? Otherwise your result is infinite. Please remember this. This condition is very important. Now 2 power n, a is 2, but a must be less than 1 to apply this formula. So if you substitute 2 power n from 0 to infinite, you will get infinite, right? Summation 2 power n from 0 to infinite. What is the value? 2 power 0 plus 2 power 1 plus 2 power 2 and so on. Your result is infinite. That is, this is unstable signal. By indirectly we can find out this is an unstable signal. So DTFT is not exist. DTFT, if it is 1 by 2 power n, then you can write your answer. You can solve it. But 2 power n, DTFT is not exist, because the signal is not absolutely summable. That means summation minus infinite to infinite, your value equal to infinite. Okay, in this example, not absolutely summable. Absolutely summable meaning we must get a finite value. So you have to be careful while writing the answer. Don't apply blindly a power n formula, because we have derived a power n u of n, result is 1 divided by 1 minus a e power minus j omega. So you may write 1 divided by 1 minus 2 e power minus j omega. That is wrong, because a value greater than 1. But Z transform you can solve it by writing some region of convergence concept that we will discuss later. That's why we go for Z transform. The limitation of DTFT, we cannot apply DTFT such kind of signals. But the same signal or the systems can be analyzed with the help of Z transform. Okay. So only one problem we will solve in today's class. Example, x of n equal to 0.5 power n un plus 2 power minus n u of minus n minus 1. So you may expect the problem in your semester and mid exams in this level only. So far we discussed very simple programs, right? Just fundamental formulas and all. Now find DTFT of 0.5 power n un plus 2 power minus n u of minus n minus 1. So let us start solving this problem. Write the formula of DTFT first. Okay. Next, first term u of n. So n 0 to infinite. X of n 0.5 power n e power minus j omega plus summation 2 power minus n. So what is the sketch for un 0, 1, 2 up to infinite? The magnitude 1. Okay. U of minus n, u of minus n, 0, minus 1, minus 2, up to this one, minus infinite. Correct? U of minus n. U of minus n minus 1, after finding time reversal, then minus 1 represent right shift. So minus 1, 0, 1, 2. The signal sketch up to infinite. Sorry, minus n, okay. Minus n minus 1. Okay. So from minus infinite to minus 2 up to like this, up to 1. So minus infinite to 1. Your magnitude of this signal is 1. That is the meaning of u of minus n minus 1. Sorry, still I am making a mistake. Minus n minus 1. Okay. So, up to this minus 1. Okay. Minus infinite to minus 1. This is the correct. Otherwise, I suggested in unit 1, u of minus n minus 1. First, do the time shift. That is best method for you. And then time reversal. So u of n minus 1, 0, 1, 2, 3, 4, up to infinite. This is u of n minus 1. Now take time reversal, minus n minus 1, then minus 1, minus 2, minus 3, up to minus infinite. The value is 1. This is what I suggested in unit 1 for you, right? How to plot u of minus n minus 1? First, do the time shift. N minus 1 first. U of n minus 1 from n equal to 1 to infinite. U of minus n minus 1, 1 to infinite. If it is time reversed signal, minus 1 to minus infinite. Okay. We follow this method to avoid the confusion. So minus infinite to minus 1. So second summation limit, n from minus infinite to minus 1. 2 power minus n magnitude 1. Okay. So these kind of problems, finding the summation limit, you have to do carefully. Okay. Like this. Now try to solve this problem. First thing, first term, 0 to infinite a power n. Okay, we may apply 1 divided by 1 minus a formula because a is less than 1 only. But second term, minus infinite to minus 1. So we don't have any formula minus infinite to minus 1. So how to solve it? X of e power j omega equal to summation n equal to 0 to infinite 0.5 e power minus j omega n. First term. Second term, summation n equal to minus infinite to n equal to minus 1. 2 power minus n e power minus j omega n. Two power n, correct? What is the problem? Sorry, the problem, given problem is 2 power n. 2 power n u of minus n minus 1. So 2 power n e power minus j omega n, right? 0 to infinite e power n, 1 divided by 1 minus 0.5 e power minus j omega. Second term, we have to simplify somehow. From minus infinite to minus 1. So second term, replace n by minus n. Minus n equal to minus infinite. Minus n equal to minus 2 power minus n e power j omega n. Right? 1 divided by 1 minus 0.5 e power minus j omega. So minus n equal to minus infinite. Minus n equal to minus n. That is n equal to infinite, n equal to 1. Right? So summation from infinite to 1 or 1 to infinite, you will get same result. Okay. Integration, if you change your limits, you have to substitute minus in front. Integration of AB equal to minus integration of B to A. But summation not like that. 1 plus 2 plus 3 is same as 3 plus 2 plus 1. So still I'm not getting the formula 0 to infinite. So what we do? 1 minus 0.5 e power minus j omega. If I wanted to include n equal to 0, what is the meaning? What is the meaning? I'm adding n equal to 0, extra term I'm adding. That meaning, if you substitute n0, 2 power 0, e power 0, anything power, that is 1. I'm adding plus 1 extra. If I substitute n equal to 0, which means in the summation result, I'm adding plus 1 extra. To satisfy that, I'm putting minus 1. So can we write like this? 1 to infinite, 2 power minus n e power j omega n. I can write summation n0 to infinite, 2 power minus n e power j omega n minus 1. Both are same, right? Introducing one extra term. By default, I am adding plus 1 with the result. To cancel that plus 1, I am adding minus 1. Now we got 0 to infinite formula. 1 divided by 1 minus 0.5 e power minus j omega plus 0 to infinite a power n. 2 power minus 1, that is 1 by 2. 1 by 2 is less than a only. So 1 divided by 1 minus 0.5 e power j omega minus 1. This minus 1 particularly for the second term only. Simplify this equation and rewrite your result. 1 divided by 1 minus 0.5 e power minus j omega plus cross multiply minus 1 plus 0.5 e power j omega divided by 1 minus 0.5 e power j omega. So 1 will be cancelled. Okay. Further, you can simplify this. You can cross multiply these two terms and simplify your result. That is also possible. So right now your result is 1 divided by 1 minus 0.5 e power minus j omega plus 0.5 e power j omega divided by 1 minus 0.5 e power j omega. You may simplify this step further by cross multiplying these two and apply the sin theta cos theta formula, and you can write the final step. So let us do that. 1 times of 1 minus 0.5 e power j omega, same, plus 1 into 0.5 e power j omega. Next, minus 0.5 plus 0.5, so minus 0.25 e power minus j omega dot e power j omega, e power minus j omega dot e power j omega, e power 0 1. Here multiply in the denominator also, 1 dot 1 minus 0.5 e power j omega minus 0.5 e power minus j omega, minus into minus plus e power minus j omega, e power j omega cancel, 0.5 0.5 0.25. So what is the final answer? Minus 0.5 e power j omega plus 0.5 e power j omega cancelled. 1 minus 0.25, that is 0.75, right? Denominator 1 plus 0.25, 1.25 minus of e power j omega plus e power minus j omega. So 0.75 divided by 1.25 minus cos omega. This is your final result. Okay. So this problem is very important for your mid exams. Don't expect a simple problem like a power n u of n del of n like that. DTFT as well as in Z transform, you may expect the problem in the question paper in this way only. They won't give simple u of n and all, u of minus n minus 2, u of minus n minus 2 like that. They will confuse, try to confuse the student always. So do the sketch carefully as our unit 1 concept, so that you won't get any confusion to plot your u of minus n minus 1. Then check your summation limits and do some modification so that you will get the standard formula summation 0 to infinite a power n format and reduce. Finally you will get this answer. Okay.